What if the greatest power source in the universe is not a star, not a galaxy, not even a supernova, but something we once believed was the ultimate destroyer of everything? What if the darkest objects ever discovered are also the brightest engines nature has ever created? Somewhere in the universe, hidden behind the horizons we cannot cross, there exists a machine already running, already converting matter into energy with an efficiency that no technology on Earth has ever come close to matching. This machine does not need fuel deliveries. It does not cool down and it does not shut off. It is a black hole. For decades, black holes were misunderstood as cosmic vacuum cleaners, silently swallowing everything around them. But modern physics tells a far more unsettling story. Black holes are not empty. They are not even truly black. They are regions where gravity becomes so intense that space-time itself bends, twists, and accelerates matter into violent, luminous motion. When gas, dust, or even entire stars fall toward a black hole, they do not vanish instantly. Instead, they spiral inward, forming a blazing accretion disk that heats up to billions of degrees. In that final dance before oblivion, matter releases enormous amounts of energy, more than stars can produce across millions of years. This alone would make black holes extraordinary, but the scale of their efficiency is almost impossible to comprehend. Black holes are the most efficient energy converters in the known universe, capable of turning up to 40% of infalling mass directly into energy. By comparison, the Sun converts less than 1% of its mass into light. Every nuclear power plant, every fusion experiment, every ingenious reactor humanity has ever built looks primitive next to this natural process. In some galaxies, a single feeding black hole emits more energy than all the stars around it combined, transforming gravity itself into raw, usable power. But the real shock lies deeper. Not only do black holes release energy from matter falling into them, they also allow energy to be stolen directly from gravity itself. In the late 1960s, physicist Roger Penrose discovered that rotating black holes drag space-time along with them, creating a region outside the event horizon where nothing can remain still. Inside this egosphere, space-time moves so violently that even light is carried along. Here, an object can be split so that one part falls inward, carrying negative energy, while the other escapes with more energy than it originally had. The extra energy does not come from fuel or fusion. It comes from the black hole's rotation. The black hole slows down and the universe pays the difference. Once this is understood, the idea of advanced civilizations changes forever. If intelligence survives long enough, stars suddenly seem inefficient and fragile. A truly advanced civilization would not orbit a sun. It would orbit a black hole. Imagine vast structures surrounding an accretion disk, harvesting radiation, siphoning gravitational energy, feeding matter carefully to maintain stability. A single black hole, slowly nourished, could outshine entire galaxies for millions of years. In the far future, when stars begin to fade and the universe grows cold, black holes may become the last remaining engines capable of sustaining life itself. Then comes one of the strangest discoveries in all of physics. Black holes are not eternal. They leak energy. Stephen Hawking showed that quantum fluctuations at the edge of the event horizon allow particles to escape, slowly draining the black hole's mass. This Hawking radiation is tiny for large black holes, but for small ones, it becomes violent and powerful. A black hole no larger than a mountain could release more energy than humanity consumes continuously. If one could be stabilized and contained, it would become a perfect power source, not burning fuel, but converting the structure of space-time itself into radiation. At this point, the frightening truth becomes unavoidable. Infinite energy is possible, but it comes with consequences. Black holes do not forgive mistakes. One orbital miscalculation, one instability in the flow of matter, and energy equivalent to billions of nuclear weapons could be released in moments. Time itself behaves differently near a black hole. A civilization living there would watch the universe age faster and faster beyond its reach. Galaxies would fade while they endure. Survival would be easy, belonging would not. Energy shapes morality. Scarcity forces restraint. Limitless power erases limits. With black hole energy, every constraint disappears. Engineering becomes godlike, survival becomes trivial, and ethics become dangerously flexible. History suggests that civilizations do not collapse because they lack power, but because they gain too much of it before they are wise enough to control it. Black holes do not just test technology, they test character. This leads to the most unsettling possibility of all. Astronomers observe objects called quasars, galaxies powered by central black holes emitting precise, sustained, almost unnatural stable energy. Most of this is natural, but some behavior defies expectation. If an advanced civilization wanted unlimited power and complete camouflage, there would be no better hiding place than a black hole. No signals, no emissions that stand out, just physics itself as a mask. We may not be alone, we may be simply early. In the end, black holes are not cosmic mistakes. They are the universe's final engines. When stars die, when galaxies unravel, when light itself becomes rare, black holes will remain, spinning, radiating, feeding, long after everything else fades. Infinite energy is not science fiction, it is written into reality. Whether it becomes humanity's salvation or its final temptation depends not on physics, but on wisdom. Because mastering the darkest power in the universe does not make you immortal, it makes you responsible. If this journey expanded your sense of scale, if it unsettled you while filling you with awe, welcome to Orbital Vistas, where we explore the universe not just for what it is, but for what it may demand of us. Space is not just our future, it is our test.